Good day, everyone. Okay, this is CP 106. We will be discussing Module 2, Utilization of Assessment Data, Part 2. So we are done with the different topics, or what I mean, different terms, no, in assessment. And then, of course, those are actually very important, especially with the concept of statistics, because they are at some point they're the foundation of whatever na ma-discuss natin for this particular subject. Here are the topics. So we have here measures of central tendency, measures of variation or dispersion. We will also discuss absolute measures of variation, relative measures of variation, measures of skewness, normal distribution, describing individual performance. We also have here standard scores, and of course, the last one would be describing relationships. Here are the learning outcomes for this lesson. At the end of this chapter, the student should be able to identify the different properties of measures of central tendency. Now, I think we are done with that. We do actually have, we did, no? Some parang review, no? At some point, we actually use quizzes for that. Okay. Identify the uses of the different measures of variability. We also have here to compute the value and make an analysis of range, quartile deviation, variance, and standard deviation of a given score distribution. But then again, we will not really focus on, or we will not give more time or much time in solving these equations, different equations for range, quartile deviation, sorry, variance and standard deviation. I am actually more on how to interpret the result, because during the exam, all you have to do here is not really to compute, but to interpret the result. No. Number four, identify the properties of the different measures of variability, and then the last five, differentiate a standard deviation and coefficient variation. Another one we also have here to apply the concept of skewness in identifying the overall performance of the students, identify the different types of standard scores, convert raw score to standard score. We have here also determine the degree of the relationship of two groups of scores. And the number 10, compute the correlation coefficient. And the last one would be we have to apply the different concepts in the utilization of assessment data. So probably we are um, to give some examples, I have to show you examples, and then you have to perhaps give your assessment or your evaluation, no, and based on the result of the problem. Okay, so we have here first describing group performance. So in describing the group performance of the students in a certain test, the measures of central tendency and measures of variability are used. Okay, when we say measures of central tendency, they are used to determine the average performance of a group of scores. So the average performance, no, of a particular group, no, kung saan bali nag-concentrate yung score, for example. So, for instance, meron tayong pa-quiz, no? And then for that section, and 10 items yung score, and then ganito yung scores niya. So, bali saan bali nagfo-focus or nagfo-fall yung most of the scores of that particular group. While when we say measures of variability, it indicates the spread of scores in a group. So take note, we term that as what they call here spread, no, spread of scores, because that is actually our concern, no, our main focus, the the spreading of scores. Okay. So, tingnan natin because ito nga, baka meron nag-score ng 1, 2, 3, and then 6, 7, 10, somewhat like that. No? How spread our scores are, sorry. Next would be measures of central tendency provides a very convenient way of describing a set of scores with a single number that describes the performance of a group. Like for example, yun talaga, meron tayong 10 items, and then ito yung mga scores, and then meron kang 20 students perhaps, and then based on your computation, you have there 5. So meaning to say, 5 yung concentration ng most of the scores, no? Okay, of that particular group. So also it is defined as a single value that is used to describe the center of the data. So yun nga, sabi ko kanina, na parang ano natin siya, parang siya yung kung saan na-fall yung most of the scores of the students, kumbaga. Okay? Sige. Next, there are three commonly used measures of central tendency. And we have mean here. We also have median, no, the other one. And then we also have a mode. Okay. Itong tatlo na to, they actually use a particular, um, they have their own ways, no, of how to determine. No? But then again, itong mga tinatawag nating measures of central tendency, hindi ito dapat basta-basta gamitin kasi meron tayong parang guidelines, kumbaga. So we actually have guidelines on how to use them. No? Nakadepende yan sa nature ng ating data. So hindi talaga basta-basta silang ginagamit. Good? So I think we have here mean and then parang dun sa ating online quiz parang napasubo tayo kasi ang daming yung parang very simple naman yung computation about mean, mode at saka median. Okay? So when we say mean, we actually refers to the arithmetic average. Alam naman natin kung anong ibig sabihin ng average, no? So we just have to add everything and then divide it by two the number of the samples. For example, we have 1 dito na score, merong 3, merong 5, okay? We also have here 8, for example, and then meron tayong 10, okay? So ang gagawin lang siguro natin, add natin yan lahat, okay? Okay? So in theory, 1 plus 3 plus 5 plus 8 plus 10.
1 plus 3 plus 5 plus 8 plus 10 is 27.
Okay, according to Siri, we have 27 here. So 27. And then of course, ang gagawin natin for us really to get the mean, no? For example, okay, all we have to do is of course to divided by 27 to the numbers of our samples. Okay? So we have 1, 2, 3, 4, 5. Okay, again. So meron tayong ilang samples. So we have 1, we have 2, 3, 4, okay, 5. Meaning to say, we just have to have, ang gagawin lang natin siguro, I have here 27, okay, so divided by 5. Nakakamiss ito. Nakakamiss naman ng ganitong format, no? Tama ba? So that's 27 divided by 5. That's it. Okay. And then right after that, we actually can get the the old naman format. Okay. So meaning to say we are just to get the, so we just have to divide it, this one. We have to divide it to the number of our samples. We actually have 5. Sige. Hey Siri,
Uh-huh.
27 divided by 5.
27 divided by 5 is 5.4.
Okay. So we have here 5.4. So the answer for this matter is 5.4. So our mean, okay. So our mean is 5.4, meaning to say, yung scores daw are actually concentrated more sa 5.4 dito banda. Okay? So see if you have your different numbers. So that is actually our arithmetic average. So let's try to look at the properties of our mean, because as I have been telling you, na meron talaga tayong nature na we have to consider first the nature of the data before you can actually use and then a particular measure of central tendency. So the first one no, used when the data are in interval or in ratio. Please take note on that the consideration here is in interval, please take note, or in ratio level. So I just have to remind everybody to our levels of measurement. So tingnan natin. Okay. And then used when the frequency distribution is regular. Okay. Regular, we also have your symmetrical or normal. Okay, but anyway, we cannot just identify really, no? Hindi naman talaga natin talaga ma-identify by the time we could actually see the our data. automatically we can't identify. We can't identify if it is regular, if it is symmetrical, or that is a normal distribution. So anyway, when we proceed to higher discussion and statistics, perhaps we can use this. Okay. So for this particular purpose, pinakita ko lang ito sa inyo para naman alam niyo kung ano lang yung properties ng ating measures of central tendency. And of course, it measures stability. Okay. But accordingly, if you are to read some references, they would actually say that mean is not actually a measure of stability. No? Why? Because our argument here is this one. Parang wala dito. Ito. Yung second, the next, ano natin, item, next bullet, kumbaga. Okay? Ito siya. So accordingly daw, no, some of the references here could actually tell us that it is not a measure of stability, no. No, hindi siya. Instead, instability. So at some point, why? Hindi talaga siya stability. That is why I'm actually contemplating if really the book that I actually use is ano ba, meron siyang flaw, no, kumbaga. So because the argument here is because the numbers can easily be affected by extreme scores. Ano may ibig sabihin natin ito? Okay. Ano kaya ibig sabihin natin ito, no? Itong easily affected by extreme scores. Ang ibig sabihin lang yan is, for example, if you have data, no? Meron tayong data na 1. Okay. Meron kang 10 items ito, meron kang 10, for example. Meron kang 9, okay, di ba? Doon lang kayo ang numbers. So you also have 8, you also have 7, okay, sige. Pero meron kang nag-1, 10, 9, 8, 7, and then meron kang 2. If we're going to look at the distance, no, ito magkalapit lang ito. Kung titingnan natin, itong mga numbers na ito magkalapit lang. But here, if we're going to compare the other one, okay, okay. If you're going to compare this one, sorry, we are to use another color. Okay. Ito naman, we also have another area, no? And then now, if we're going to compare now the two, ang layo ng scores, no? And this is now the time that I will tell you that this is actually example of extreme scores, a set na meron talaga siyang extreme scores, no? Parang end-to-end point, no? Kumbaga. And then because of that, if we're going to look at, no, kung ito yung isosolve natin, walang problema, baka yung makukuha nating average malaki pa, no? But if we're going to include 1 and 2 here, most probably it will be dragged down, no? So it will actually maging pull down yung value ng ating mean because mean is actually can be easily affected by extreme scores. Now, because of that particular nature, that is why hindi stable yung tinatawag nating mean. Okay? Sige. So yun lang, para lang maano ninyo, no? Okay, number 4, next bullet, may not be an actual score in the distribution. May not be an actual score in the distribution. Ibig sabihin, kung titingnan natin yung example na ito, ang nandito lang na number, yung score ay 1, 3, 5, 8, at saka 10. Wala tayong nakikita na 5.4, correct? Okay. So, ito yung ibig sabihin na may not be an actual score in the distribution. Okay. Yung iba pa, baka ang lalabas pa dito, ma-shock na lang ka nga yung magawas diri kay 6, for example. Or pwedeng mo gawas 7. Okay? And then, of course, if you're going to go back to your data, wala ka nakikitang 6, wala ka rin nakikitang 7. Okay? Next, of course, this is actually very easy to compute if we're going to look at the formula. Okay? No, we could actually really agree that this can be easily be computed. Okay? Okay. Next, the sum of each score's distance from the mean is 0. Ibig sabihin nito, actually, hindi natin ito gaanong ma-appreciate. No? Hindi natin ito gaanong ma-appreciate kasi kailangan kasi ito i-solve. No? Kung pupunta tayo sa yung mga standard deviation, kumbaga, no? And so on, yung equivalent niya nito ay 0. No? Ibig lang sabihin nito, the sum of each score's distance, no, yung distance daw nila, it is actually equal to 0. So used to compute other measures, such as, of course, before you will get standard deviation, you have to compute first mean, and part of which you should have for coefficient of variation, kailangan talaga ng mean. At saka itong natitirang dalawang terms na to, kailangan talaga nila ng mean. So, kailangan mo talaga i-solve ito muna before you can get them. Okay? Okay, next would be median. Ito namang median, this is, I think, parang okay to sa akin. Okay. So for median naman, it refers to the centermost score. Meron naman tayong keyword dyan. May pa-keyword tayo na tinatawag nating tinatawag nating centermost score. No? When the scores in the distribution are arranged according to magnitude, please take note that it refers to the centermost score. It refers to the centermost score when, meron tayong condition dito, when the scores in the distribution are arranged according to magnitude. Meaning to say, I would like to emphasize this one, or I have to reiterate this, that for you to really para tama, no? For you to get the correct score or digit for median, you have to arrange them, properly. You have to arrange the digits, in a particular manner, which is nakadepende sa inyo kung gusto ba ninyo ng ascending or descending. Okay? Basta dapat naka-arrange siya. Okay. So hindi pwede na the same yung sa mean kasi hindi kailangang i-arrange yung numbers. So kahit pwede kang meron kang data na 9, 10, 12, 1, 7, so hindi kailangang i-arrange. But for the case of median, no, we really have to arrange them because we are to get the centermost score. Okay? Later on, ma-appreciate natin ito kasi meron tayong gagawin sa median. So let's try to look at median. Sige, ano na lang, pakita tayo ng a very quick na example siguro para mas ma-appreciate natin itong sinasabi natin. Okay. Like for example, meron tayong arrange natin one, we have two, we have three, we also have four, we have five, arrange natin lang automatically. Six, seven, we also have eight, nine, okay, nine tayo. For example, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is an example of, this is an odd ito. No? But 9, okay. So if it is odd, so ano mangyayari? Let's try to look at, identify the centermost score. So ang centermost score would be here, 5. Tama ba? Okay. So the centermost score is 5. Okay. Walang problema. Ang dali tingnan. Therefore, for this particular example, our median is 5. Kung hanapin natin yan, it is 5. Okay. Now, for the case of an even number, so kung even naman yan, so let's try to have it, 1, 2, ang hirap magsulat. 4, 5, 6, 7, 8, 9, 10. Okay? And this is actually even, correct? Okay. Now let's try to look at kung ano yung magiging sagot natin for this, no? So meron tayong 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So ang center, dalawa, no? 1, 2, 3, 4 at saka 1, 2, 3, 4. So meaning ang centermost na score ay 5 and 6. Okay. And of course, we cannot answer 5 and 6 because ang talagang kukunin natin is actually the centermost score. And this is not the centermost pa. So, ang gagawin talaga natin, we have to add the two digits. No? We have to add them. Okay, so meaning to say we have 5. Sorry, for number 5. So 5 plus 6, and then divided by 2. Then the answer to that is your median. Okay, so 5 plus 6, that is 11 divided by 2. So you can actually get the number. Okay, so that is for your median. Now, let's try to look at the properties of your median. It is used when data are in ordinal level of measurement. Try to look at it is in ordinal level of measurement. Now, bakit importante yung ordinal? Remember, kung titingnan natin, dapat talaga naka-arrange yung numbers natin, arranged according to magnitude. No? Merong necessity. And then you can now appreciate why there is a necessity for us to arrange them according to magnitude. Okay? And then yung data na pwede lang sa median ay yung ordinal level of measurement. Used when the frequency distribution is irregular or skewed. So alam na natin na pag irregular or naka-skewed yung frequency distribution natin, automatically median ang gagamitin natin. Okay. One of the measures of central tendency, median. Okay. Again, we cannot appreciate this more because we have to discuss pa the other topics. But then again, if during your CPE 105, kung nakapag-discuss man kayo ng frequency distribution, or what I mean is that the normal distribution or your skewness, baka ma-appreciate niyo ito. And the next, used when the middlemost score is desired. Kung gusto talaga nating malaman kung ano yung middlemost score. Okay? And then used when there are extreme scores. Ito ang kagandahan kasi ng median ay hindi siya naapektuhan ng extreme scores. Kasi nga, hindi naman natin siya i-add at saka i-divide. No? So meaning, ang gagawin lang natin, di ba kung titingnan natin yung example natin, no? Yung halimbawa natin, meron tayong 1, okay? Meron din tayong 10. Okay? 'Di ba? Na very opposite, no? So the numbers are here, very very maliit, nagkagamay. Dire kay nagkadako po ang number, no? And these are actually very extreme scores. Now, your median cannot be affected, or it is not actually affected by extreme scores. So if there are a lot of extreme scores, perhaps you can use median. Okay. Next, not affected by the extreme scores because it is a positional measure. Now, please remember the other term. Meron siyang ginamit na term na positional measure. Yeah? Kasi ang parang hinahanap lang natin is ang centermost, di ba? Or the middlemost score. So therefore, this is positional measure. Okay? Sige. Next, may not be an actual observation in the data set. The same with your mean, no? Kasi nga, ang mangyayari, 'di ba, for example, kung naka-add yung numbers natin, automatically makukuha natin yung number kung sino yung nasa middle. Pero there are times, kaya nga sinabi to, may not be an actual observation in the data set. It is because, like for example, kung naka-even naman siya, di ba, i-add natin tong dalawang digits na to, and then you will get something. And that is beyond the number in between. Di ba? So kung i-add natin yan, hindi natin mahanap yung number, yung data from 1 to 10. Hindi natin siya mahanap dyan. Okay? The same with your mean. Okay, I hope you understand it. Next is your mode. Mode is the last measure of central tendency, and then we actually have different types of mode. Now we have unimodal, we have bimodal, we have trimodal, and multimodal. So when we say mode, it refers to the scores that occurs most frequent. So ang consideration na naman dito is yung tinatawag nating most frequent na nakikita in the score distribution. Okay. Like for example, meron tayong score na 6, another score na 6. We also have 6. 666 na ito. Erase natin. Ang pangit. Okay. So for example, meron tayong score na 7. Another 7. Meron tayong 8. Okay. Meron tayong another 8 dito. Meron tayong 1, 3, 9, 6. Another thing is 5. Okay. For example, yan yung score distribution natin. So, ang sinabi dito sa definition, it refers to the scores that occurs most frequently. And then, kung titingnan natin, yung 1 isa lang, yung 3 isa lang din. Okay, tama. Okay. Yung 1 isa lang, yung 3 isa lang din, yung 9 isa lang din yung 6, and then of course, yung 5 isa lang. Okay. Kung titingnan natin yung 7, parang dalawa ito lumabas, yung 7 natin. So we have 2 7s here. We also have 2 8s. Okay. Therefore, This one is actually frequently occurred. 8 also frequently occurred kasi nga nakadalawa tayo. Okay. Sir, paano yan? May dalawa. Meron tayong 7. Therefore, ang sagot nito would be, the answer for this example is 7 and 8. Okay. Wag i-repeat, no? Wag i-repeat. So, yan. Okay. The answer for, meaning to say, for this particular example, our mode are 7 and 8. Okay. And this is an example of this one. This is an example of a bimodal. Okay. Bakit bimodal? Kasi dalawa yung numbers natin. We have 7 and 8. Okay. Pag tatlo naman, you also have here trimodal. Okay. Sige. Pag isa lang, of course, unimodal. More than three, of course, we will use multimodal. Okay, I hope you get it. Now let's try to look at the different properties for mode. Okay, of course, the first one, used when the data are in the nominal level of measurement. Take note, naka-nominal lang siya. So yung pinakamataas, yung pinakamababang level ng level of measurement. No? Next, used when quick answer is needed. Of course, kasi hahanapin mo lang kung ano yun, yung most frequently na nag-occur sa data set. Okay. Used when the score distribution is normal. The same with your, what do you call this? The same sa, ano natin, sa mean that dapat, no, yung distribution is actually normal. And of course, sa mode pala, hindi natin dapat makalimutan that for in terms of para mas mapadali, no? Yung sinasabi nating pag-identify yung nag-occur mostly na score, dapat siguro natin i-arrange siya ascending or descending order. Okay. Not necessarily naman na kailangan siyang i-arrange, but para mas madali nating ma-count yung mga uulit-ulit na mga numbers, we have to arrange them properly. Okay. Mas dali siya. And then can be used for quantitative as well as qualitative data, and then may not be unique. No? May not be unique daw yung data natin. Okay. Not affected by extreme values kasi nga ang hinahanap natin ay most frequently occur in it actually occurs most frequently in the score distribution and may not exist at times. Bakit ba nasabing may not exist at times? Kasi there are examples kasi na wala talagang mode na lalabas, no? Like for example, ito, kung tatanggalin ko to, no? Ayan. Kung tatanggalin ko yan, 13965, tsaka kung tatanungin ko kayo kung ano ba yung mode nito, wala. Walang mode kasi walang nag-uulit-ulit. Okay, so 1, 3, isang 1 lang, isang 3, isang 9, isang 6, at saka isang 5. So this is an example of an example of that particular statement na may not exist at times. Okay? Next, the different measures or variation or dispersion. So this is now the time that I've been telling you that the other one is actually concerned on the center of a particular score, kung saan nag-focus yung score of a particular group. Here naman is more on variation is or dispersion. Gaano ba kakalat-kalat yung scores, no, of a particular group, no? How dispersed are the scores? How dispersed scores are. Yeah. Measure of variation is a single value that is used to describe the spread of the scores in a distribution. So again, single value din yan. And because of that value, you can actually judge na evaluate if the scores are more spread or not. Okay. The term variation is also known as variability or dispersion. There are several ways of describing the variation of scores. Now, the first one is the absolute measures of variation and relative measures of variation. I think for this particular class, we really have to identify each, no? Kung ano ba yung mga formula or ano yung mga concept, no? That belongs to absolute measures of variation and relative measures of variation. Again, our focus here is not really to compute, but to to how to interpret the result. So ito yung mas concern natin. For measures of variation or dispersion, we will be discussing or we'll be talking about range, interquartile range. We also have here quartile deviation and of course the standard deviation. Okay, for range, range according to definition is the difference between the highest score and the lowest score. I think um, sa lahat ng measures of variation or dispersion, yung range ata yung may pinaka simple na when it comes to calculations, ito yung pinakamadali, no? Because all we have to do is to get the difference between the highest score and the lowest score. So for the interpretation naman, if the range is large, so I think I did mention this that the focus for this discussion is not for computation but to interpret the result of a particular computation. If the range is large, the scores are more dispersed. No? On the other hand, if the range is small, the scores are less dispersed or less scattered or homogeneous. Okay, so please take note of that interpretation. For the properties of range used when the score distribution is normal, again, we cannot appreciate what is really distribution, what is really score distribution is normal all about, no? Anyway, we will be discussing it later, and let's try to pick up something, no, about it. And used when the data are in interval or in rational level, no, on a ratio level of measurement. So please take note of that interval, and then of course ratio. So used when quick answer is needed kasi nga sa sinabi ko, very easy to compute siya. Rough estimation of variation or distribution or okay, again, this is a rough estimation of variation or dispersion. Most likely, we can actually say that this is, yeah, technically rough, no? Kasi nga, very simple yung ginawa, no? Kinuha lang yung difference between the highest score and the lowest score. So, if we are to really look at the how dispersed scores are, no, or how varied they are, you have to go through the other measure of variation power dispersion. Okay. Easily affected by extreme scores kasi nga, no, kung kukunin natin, so mas madali siya talaga, maapektuhan talaga siya, no? So, like for example, if you have there 9 minus, for example, the highest score is 9 and the lowest score is 8, no? Kung titingnan mo yan, so that's actually most likely nice yung answer, no? But if you're going to have 9 minus 1, so if you're going to look at the value, no? Extreme scores yan kasi magkabila 9 at saka 1. So, it could actually affect really the difference of the two scores. Okay. So quick and easy to understand, yes, and then only two scores are needed. Okay, only two scores are needed to compute the value of range. No, ang una lang nating hahanapin, so of course you have to arrange the scores in a particular order, and then try to look at kung ano yung highest score and then the lowest score. Okay. Next one, we have interquartile range. Now, for interquartile range or IQR, it refers to the distance between the third quartile and the first quartile. Okay. So for interpretation, the larger the value of IQR, the more dispersed the scores are from the median value, or the smaller the value of IQR. Okay. So if the smaller the value of the IQR, okay, the more clustered the scores are from the median value. I think we really have to look into the interpretation, no, of, of this different concept. Okay. For properties, someone used when the data are in ordinal level. Please take note that it is in the ordinal level of measurement. Okay. So most likely you really have to arrange this. Now, used when the frequency distribution is irregular or skewed. Okay. Again, this will be more this will be appreciated siguro at the later part. Reduces the influence of the extreme scores. Okay. So most likely, although naapektuhan ito sa mga extreme scores, but then again, because of the nature of the IQR, it actually reduces the influence of the extreme scores. So considers only the 50% of the scores distribution. Okay, I think this is the reason why this particular measure of variation or dispersion actually reduces the influence of it. No? The other one is not easy to calculate as compared to range kasi nga if you're going to remember no the different formulas for IQR, so you could actually compare it to range nga dali lang. So anyway, isa-isahin natin yan mamaya. And of course, the point of dispersion of the scores is the median value. Okay? Again, the point of dispersion of the scores is the median value. Why the median value? Because again, we only get here 50%. No? So dito yan siya nanggaling. No? Because of this median value, no? Kasi nga 50%. Yan. Next, I have quartile deviation or QD. It refers to the average deviation. Now, please take note that we are actually talking about the average deviation of the third quartile and then the first quartile from the value, again, from the value of the median. So for interpretation, the larger the value of QD, okay, we actually have another interpretation. The larger the value of QD, the more dispersed the scores. Okay, and then the smaller the value of QD, the more clustered the scores from the median value. So again, do not pattern it with based no on the interpretation of each measure of variation or dispersion. Uh, please avoid giving pattern or trying to look for patterns sa interpretation because at some point nag-iiba siya. No? Like for example, for quartile deviation nag-iiba. The larger the value, the more dispersed. No? The smaller the value, the lesser the more clustered the scores are from the median value. Okay. The properties used when the data are in ordinal level of measurement. Okay, so that's it. Okay, so used when the data are in ordinal level of measurement. Okay, used when the frequency is again irregular or skewed, and then reduces. I think they actually have the same. Considers only the middle 50% of the distribution. Okay, the point of dispersion is also the median value. Okay. Okay. Next would be the last one we have is the standard deviation. It refers to uh, the average distance that deviates from the mean value. Okay. So if the value of s is large, so you really have to take note of this. If the value of s is large on the average, the scores and distribution will be far from the mean. Okay. Therefore, the scores are spread out around the mean value. The distribution is also known as heterogeneous. If the value of S is small naman, the average, the scores of the distribution will be close to the mean. Hence, the scores are less dispersed or what we call homogeneous. Okay. So, of course, you have heterogeneous here. They're much spread no, around the mean value compared to the other one. So, we use when the data are in interval or in ratio level of measurement. Then use when the frequency distribution is irregular. What I mean is regular, okay, symmetrical or normal. Okay. The most important measure of variation or dispersion is your standard deviation. The most commonly used to measure a variation, particularly in research, yan yung ginagamit na at saka hinahanap na value, no? Okay. When it comes to research, shows variation of the individual scores, no? Shows variation uh, of the individual scores about the mean. So that is your standard deviation. So of course, those five are examples of what we call the absolute measures of variation. So there are five types of absolute measures of variation, which are very important. Okay, which are very important in analyzing the variation of scores of the students in certain assessment procedures. These are the range, interquartile range, and quartile deviation, and variance and standard deviation. Okay, for the range, of course, you all know that range is just the difference between the highest score and the lowest score in the distribution. Okay, so the simplest and the crudest measure of variation, no? Kasi nga, ito yung if you really want to have a quick answer, no? In terms of really looking into the how dispersed scores are, you have to look for a range, no? Pinakadali, no? Is quick and easy to understand, of course, because of course, the interpretation is very easy. No? So only the highest score and the lowest score are needed to be considered. So only the extreme scores are needed to be utilized without considering the other scores. Yeah, of course, because I've been telling you that by the time you will be computing for range, you have to arrange first the scores to in a particular order, and that's the time that you will look into the highest and then the lowest score and see the difference between the two values. Okay, so this is an example of range. Okay, the first one in the first side column, this is the range for ungrouped data. And then this is the range for grouped data. Okay, please take note that R is the range value, H is the highest score, and then you have here the LS as the lowest score. For the group data naman, okay, so where R range the value, HS is the the upper boundary of the highest score, and then LS is the lowest boundary of the lowest score. Next would be the interquartile range. So IQR is the difference between the third quartile and the first quartile. And because of this, it could be actually given into this particular formula. IQR is equal to Q3 minus Q1. Kasi ang hinahanap dito, difference between the third quartile and the first quartile. So the QD, or the quartile deviation, indicates the distance we need to go above and below the median to approximately include the middle of 50% of the scores. So again, we have it actually indicates no above and below the middle score, the middle 50% of the score. The formula, or QD, is based on the range of the middle 50% of the scores instead of the range of the entire set. Okay, so formula, the formula in computing the value of the quartile deviation is QD is equal to Q3 minus Q1. Okay, so naka Q3 yan. Okay, so that is the value of the third quartile, and then of course the Q1 is the value of the first quartile. Okay. And then capital letter N, and that's it. So that's the formula of it. Where, yeah. Okay. Next is the variance and the standard deviation. Standard deviation is the most important measure of variation or dispersion. So, sinabi ka kanina nga, most of research, they actually use standard deviation as one of the tools no, na ginagamit nila. So, the average distance of all the scores that deviates from the mean value. Kaya ang tinitinan dito ha, yung value that deviates no, the average distance of the score. Okay. It shows variation about the mean, also known as the square root of the variance. A variance is one of the most important measures of variation. It shows the variation about the mean. So of course, again, it talks about how vary is will be the scores no above or below mean no, or around the value of the mean. So if we're going to look at the screen, meron tayong dalawang formula no, for our variance, so for population and variance. Okay, and this is for the sample variance. So please take note of the variables that are actually used. No, they actually have different variables if we're gonna look at it. So for example, Kinesha for population, and this one is for sample variance. For population capital letter, and then for the sample variance is n minus 1. Okay, so please take note of the differences of the two equations. And now let's try to look at the different steps in solving your variance for ungrouped data. No? So alam na natin during our CP 105 what's the difference between ungrouped data and a grouped data. Of course, the first one is for us to solve for the mean value. Okay. And then number two, subtract the mean value from each score. Number three, square the difference between the mean and each score. Number four, find the sum of step four. And then, of course, the last one would be solve for the population variance or sample variance using the formula of ungrouped data. Let's try to look at again the formula that you are to use. Now, please don't forget for the variance for ungrouped data. Now, let's try to look at the different formula for your standard deviation. Okay, so once again for population and sample may iba't ibang notations tayo. Okay, this is for population and this is for sample. Again, this one and of course this one. Please do not forget the different variables. No, so ito yun siya. This one also, no, iba siya, ibang iba. Okay, and this one of course, that one. Okay, so that's for standard deviation. And for this, let's run through the different steps in solving standard deviation of ungrouped data. Okay, solve for the mean value, yes, of course, no, and then subtract the mean value from each score. The third one is square the difference between the mean and each score. And then we have to find the sum of the step four. Then the last step is to solve for the population standard deviation or sample standard deviation using the formula of ungrouped data. Okay. Note if the variance is already solved, take the square root of the variance to get the value of the standard deviation. So please take note na yung value natin no, for population and sample naka-square yan. For you to identify the value of the standard deviation, all you have to do is to get the square root of it, no, to find the value of standard deviation. Okay, now let's try to look at some example or an example, no, for us to get the value of our variance and standard deviation. Below are the scores of 10 students in mathematics quiz consists of 20 items. We have to compute the population and sample variance and the population and sample standard deviation. So try to look at the table and I would like you to compute no on your own. Along the way siguro sa panonood ninyo nitong recorded lecture, try to compute or recompute baka kasi meron tayong may nakaligtaang number no or number na makompute no. Sige. Okay, of course this is the value here, the 130. The 130 is the sum of all x no ito. It is actually equivalent to 130. And then of course, to get the mean, all we have to do is to divide, no, 130 divided by the number of these, no. So since we are this is 130, no, and then 10 students tayo, therefore 130 divided by 10. That is why we get 13 as our x. Okay, now let's try to look at the value of this one. Okay, this. Okay, so -7. Okay, so again, we have to get this and then minus the value of x bar. Okay, and these are the answers. Okay, and then right after that, we get the value of non square. So -7, squared 49, and so on. Okay. And then right after that, no, pagkatapos natin kunin ito, we have to get the total of these, no? That is why we have 186. Okay. Now right after that, we have to plug it in sa ating equation. For population variance, we have, and then of course for our sample variance, So of course 10 ang ato ang atong gigamit kasi according to the problem, these are the scores of 10 students. And then of course pagdating natin sa sample variance n minus 1, therefore that is why 9 yung nakikita natin dito. So 186 divided by 9. Next is the population standard deviation and then the sample standard deviation. Okay. Dito naman naka-square tayo dito. So meron na tayong value for this, no? We also have a value for this, no? So the answer is 4.31. Kindly check with your calculator. And of course, the same. No, we already have the value of this one. And then since 10 man yun, so 10 minus 1, we have 9. So the remaining is here. Okay. Now, if you're to look at the value of your variance kanina, you just have to get the square root and then that's the answer. No? Okay. Next would be the relative measures of variation. For the relative measures of variation, we actually have first the coefficient of variation. It shows a variation relative to the mean. It is used to compare two or more groups of distribution of scores. No, if we have different groups, no, and then we compare the distribution of scores, we actually use coefficient of variation. And usually expressed in percent, the smaller the value of coefficient, so here is the interpretation, the smaller the value of coefficient, more homogeneous the scores are. So mean to say, hindi siya gaanong varied. Okay, so that's the interpretation. The higher the value of the coefficient of variation, okay, the higher the value, the more spread, no, ay yung scores natin. Okay, take note of the interpretation. Okay. Now, to compute your coefficient of variation, we will be using this formula. CV is equal to S over X bar times 100% since naka-percentage yung ating usually no, it is expressed in percent no, yung coefficient of variation natin. So where S is the standard deviation and of course the X bar is the mean value. Please take note of the formula and let's try to look at this example. Again, please recalculate or recompute no, the value for section A, B, and C for us to check if that is really the true value. No? Okay. So we have here we have three columns, section A, B, and C. And according to here, we have how many samples do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think we have 12. No? So the population here is 12. Okay. Okay. The respondents would be 12, no? So nakikita naman dito. N is equal to 12. Yeah. Okay. That's it. N is equal to 12. Now let's try to get the sum of x, no? So the sum of x is 185. So 185 daw itong lahat. Kung ito total natin, so that is equivalent to 185. For section B, we have 184. And for section C, the total of this is 170. Now to get the x bar, okay, to get the value of your x bar here, yan, all we have to do is divide 185 to 12. Okay, let's try to look at 185. Hey Siri, 185 divided by 12.
105 divided by 12 is about 15.4166.
Okay, so we are in the two decimal places. That's why it's instead of 15.4166, that is 15.42. Now the standard deviation, the S here is 3.75. Okay, that's the value of it. No, you just have to follow. Now, if you're going to look at no, they are actually interrelated with each other. Therefore, you cannot compute a coefficient of variation. Although yung equation is very simple, but then again, you cannot compute coefficient of variation without knowing how to compute your standard deviation. Okay. So as for the case here, the value is 3.75. Please run through. No, paki-run through ako kung bakit ganyan yung sagot ng ating standard deviation. So at some point, this will be a practice to you. Okay. So you have here 3.75 accordingly. Now for this case, meron tayong total of number, which is 184, and then of course the yeah, yung number ng estudyante, and of course the value of your mean, the mean average, no. So again, 184 divided by 12, you get 15.33. And of course the standard deviation once again. Yeah. And so on for section C. Okay. Okay, so let's try to look at the value of your the value computation for section A, B, and C. So for section A, you just have to input everything. Okay. So our formula for coefficient of variation is equal to S, no, which is the standard deviation, divided by the mean value, the X bar times 100%. According to here, the answer is, so the answer is 24.32. Again, recalculate. Paki-recalculate ako. Pa-calculate again. So 24.32. Next for section B. For section B naman, of course, our standard deviation is 2.35. Okay. And then our X bar is 15.33 times 100%. Okay. You will get this one. The coefficient of variation for B. Please take note how to interpret a coefficient of variation. Next will be the last one, the section C. Plug in everything and you will get this one, 28.51. Again, recalculate. Okay, now since we already got the value of the coefficient of variation for section A, B, and C, then let's try to look at the interpretation of the interpretation for the three sections. So accordingly, the CVA, or the coefficient of variation of section A, is equal to 24.32%, and then the coefficient of variation for section B is 15.33%, and 28.51% for section C, which means that the scores in section B are less scattered. So if we're going to look at the value here is smaller, no? Quite smaller compared to the two. So 15.33, therefore the interpretation is less scattered than the scores in section A and C. Okay. So in other words, the scores in section B, sorry, are more homogeneous than the scores in section A and section C. Okay. More homogeneous ang ato ang section B because siya yung may pinakamaliit na compared to the three sections, siya yung may pinakamaliit na percentage. And then according to the interpretation for coefficient of variation, okay, we're going to look at here, the smaller the value of the coefficient of variation, the more homogeneous the scores are. Therefore, this is correct. Okay. Another way to interpret the three score distributions is that scores in section C are more spread out than the scores in section A and section B, or the scores in section C are more heterogeneous than the scores in section A and section B. So this is so nice because the interpretation is just easy, no? The problem here is that you know how to compute for the different what you call this, a variation or dispersion formula. Okay, so that is for our coefficient of variation, no, that belongs to the relative measures of variation. We actually have more. We actually have measures of skewness. We also have here the normal distribution describing individual performance. And then, of course, the actual or the raw scores. And then, of course, the standard scores, okay? The different standard scores, and describing relationships. I think that's the last part of the discussion, no? Describing relationship. Okay. So we will end the discussion here first. Thank you so much, everybody.